Okay. So in terms of the background, as all of you know, Indian government has set up very ambitious roadmap for renewable integration. Indian government is looking at adding 100 gigawatt solar as well as 60 gigawatt of wind energy into the grid as part of the national commitments towards climate change. If you see current scenario, then already India has been deploying specifically wind energy for more than a decade now, or more than almost 2 decades. There is almost 27 gigawatt of wind energy which is currently integrated onto the grid. It is mainly concentrated in the coastal regions because those are the regions where most of the wind energy is available, with Tamil Nadu being the state with maximum penetration for wind energy. And if you notice the expected chart in 2022, same states are expected to continue to build more and more renewable deployment, particularly with the wind. So again, starting with Rajasthan, Gujarat, Maharashtra, Karnataka, Andhra Pradesh, Tamil Nadu, Telangana. So these are the states which are again expected to have more than 90-95% of the wind energy installed even in 2022. Whereas if you consider solar, then solar is starting off with a relatively very small base. 2 years back, India had less than 1 gigawatt of solar installed. Now last year itself, India has deployed more than 3.5 gigawatt solar. So total installed capacity is now crossed 6 gigawatt. At the same time, we are looking at going from 6 gigawatt to more than 100 gigawatt. So almost 15x increase in the deployment in next 7 years. Out of that, 60 gigawatt is expected to be large scale utility scale projects, and within those 60 gigawatt again there is more than 20 gigawatt which is going to be in form of large ultra mega solar projects, and then there is a 40 gigawatt which is expected in terms of rooftop solar, which will be more distributed. Now when you consider some of the challenges for renewable integration, again everyone knows about the variability and intermittency challenges, but one of the big issues which comes is also in terms of at a system level. So not talking about sort of variability of an individual solar or wind farm, but for example, some of you may be familiar with the California duck curve. This was a curve which California Independent System Operator created a few years back to show how California's net load shape is going to change looking at all the renewables expected on the California grid. So we try to create something similar looking at the 100 gigawatt expected solar, and we think that it sort of resembles camel. So instead of calling it Indian duck, we are calling it sort of Indian camel. But at the same time, there are a number of things which are still variable, and that may have a big impact on the how this load shape shapes up. For example, right now most of the public or private utilities, they are actually worried about their afternoon peak load. So there are a number of initiatives for example, reducing afternoon peaks, such as thermal storage and other deployments. So if that continues, then actually this the afternoon valley will become even worse off. At the same time, there is electric vehicle is expected to also become popular in India within next few years, thanks to various governments incentives. And if that happens, it is again depends on what type of charging infrastructure is provided and what type of policies are provided for that. For example, if all the vehicles are charged only at homes, once people go back home after 6 p.m. or 7 p.m., then it is going to actually make this problem much worse, and maybe from camel it will turn to a giraffe. Whereas if the public charging infrastructure is provided, if we can have these vehicles charging in during the day, or maybe providing some vehicle to grid type services during evening, then actually this all the energy storage deployed in electric vehicles can actually provide a solution for this challenge. Other issue in India, because again one thing which happens, and probably both Deva and Atul will talk about it, is in India I think everyone is just fixated on capital cost of storage technologies, and there is a big debate, is India ready for energy storage technologies? But if you consider right now what is happening is that, for example, there are a number of locations such as say Andaman Nicobar Islands, where right now most of the load is served by diesel generators, and for reducing this diesel consumption, Indian government has been trying to deploy solar energy, but with solar, with the type of intermittency which is there, you have to keep some of the diesel generator units on completely standby operation, operating maybe at no load to meet the ramp rate requirement. So we had done this study almost 18 months back to show that by adding just something around less than 1 megawatt hour of energy storage, they can significantly cut down on the ramping requirement and shut down couple of the diesel generators which are operating completely on standby mode. So these type of applications are there where energy storage is already economically viable, because you are looking at the cost of diesel generation at somewhere around 25 to 30 rupees per unit, and particularly if you are operating some diesel generators on no load condition, then actually your marginal cost for those is even more than 40, 50, or even in some cases 60 rupees. So those are the type of sort of low hanging fruits which we need to focus on and start deploying storage, and once we start deploying storage, the costs are going to come down very rapidly. The other interesting application is ancillary services, and this is an application which has driven lots of deployment for energy storage technologies around the globe. So in last 2 years around the globe, there are more than 400 megawatt of energy storage technologies deployed, mainly lithium-ion batteries, but also some advanced lead acid and flywheel chemistries for demonstrating energy storage application for this frequency regulation, where you are trying to match the load and supply on a second by second basis. So we have done some studies to show that actually India has a great opportunity to leapfrog in this area, because right now India does not have an ancillary service market. We have some some norms where we are expecting the conventional generators to provide AGC control and respond to these frequency deviations, but India is just about to launch an ancillary service market starting 1st April 2017. Unfortunately, in the pilot which was launched earlier this year, CERC allowed only central thermal generators to provide this service, but we are expecting that by April next year, CERC will remove that limitation and allow energy storage and demand response technologies also to participate in this segment. And if that happens, that will create 1 gigawatt to 3 gigawatt of market, where already around the world it is demonstrated that energy storage technologies are most competitive in that area, and that is a low-hanging fruit, because in one case, sometimes the regulators feel that this is a luxury, that in India we have issues related to energy access and other challenges which we need to solve first, but this is something which we are talking about just 1% of the load. So right now, with around 150 gigawatt of load on the grid, we are looking at less than 2 gigawatt of requirement in terms of such frequency regulation, and immediately you can take the Indian grid from 20th century to 21st century. So what we actually trying to sort of pass on the message to Mr. Piyush Goyal or some of the other senior officials is that if they want to show something by 2019 election, a measurable performance improvement, what has happened to the grid, then this is a low-hanging fruit. Even if they implement these rules properly in April 2017, by end of 2019, we can have a significant difference in the grid frequency in India. The other area is, again, we are not neglecting the energy access issue. So actually we have launched an initiative called Microgrid Initiative for Campus and Rural Opportunities, where we have set a goal of reducing the cost of energy by 30 to 50% within next 3 years. And again, we are working with all the members of Indian Energy Storage Alliance and try to achieve ways in which we can reduce this cost. Again, we are not focusing on just capital cost reduction. We think as the volume increases, that is naturally going to happen, but at the same time there are ways in which you can use the data from how the sites are being operated and extend the life of the batteries or extend life of some of the components, avoid failures, or even in the first case optimize the design of these microgrids, which can bring down savings almost instantaneously. So there are a number of areas we have identified where we are also trying to bring in transparency in terms of how the financing flows to microgrids, and also bridge in that gap in terms of scaling up microgrids in India. And we'll also be looking at campus microgrids, because in India we believe that there is a huge opportunity for smart townships and cities. Obviously, Indian government has this big smart cities program, and those things will happen, but we don't need to wait for those smart cities to start construction or renovation before we start deploying energy storage. According to our studies, there are more than 300 townships being built all over India, which are somewhere between 5 megawatt to 50 megawatt load, with something around 50 to 100 or maybe couple of hundred acres of townships with mixed usage between residential, commercial, or in some cases industrial townships. And right now these townships are getting built on outskirts of cities, so they face significant amount of problem in terms of grid interruptions. So even in case of sort of Delhi, in Gurgaon or Noida, there are a number of townships who are using diesel generators for anywhere from 6 hours to 16 hours per day. So there are again, I think, low-hanging fruit available where deploying renewable energy as well as energy storage can help these townships become greener and cleaner immediately. In terms of energy storage landscape, there are a number of technologies which are coming up, and this is a big change as compared to 2004 when we started working on energy storage, when handful of 4 or 5 technology companies were available. But again, if you see, it's not just only about lithium-ion batteries, but within lead acid, sodium-based batteries, flow batteries. In each of the categories, there are more than 10 large commercial companies who are trying to bring commercial solutions to the market. So we think that this competition is good for customers, and also there are it's not just about batteries or storage. There are inverter companies, power system companies, there are project developers. So again, the whole ecosystem is getting developed in a big way. In terms of future advances, again, we think that energy storage is a very much evolving field. There is no, although in some cases lead acid batteries have been dominant for last century, lithium-ion batteries have recently started gaining more momentum. But at the same time, I think that number of other technologies may also come to commercialization in coming years, where, for example, lead acid batteries are trying to improve their cycle life, whereas flow batteries are trying to improve their efficiency. So through these number of changes, we are going to have a very dynamic situation where multiple technologies may get applications. In terms of energy storage trends, capital cost trends are pretty interesting already as compared to 2008, when cost of lithium-ion cells were more than $2,000. Already the cost have come down at a cell level less than $400, or in some cases even $300 per kilowatt hour. And this trend is expected to continue with some of the large-scale manufacturing coming up. It is expected that the cell level cost will go down to $200 per kilowatt hour within next 3 to 4 years. At the same time, cycle life is also improving. So when you ultimately consider the total cost of ownership, then by combining both these trends, there is a exponential reduction happening in terms of the levelized cost of energy from the energy storage technology. So we think already for diesel replacement, energy storage technologies are cost competitive, but as the technology deployment goes up, the cost comes down, performance improves. Even renewables plus energy storage can become a viable alternative for grid peak power. One of the key part related to this is policies and initiatives, because again we have seen it around the globe that government policies play a key role in giving a clear investment signal to the market and also encouraging customers in terms of increasing the demand base. So in India right now, the good part is there are a number of existing government initiatives which, although are not specifically meant for energy storage, each of them have some components which are related to energy storage. For example, National Smart Grid Mission talks about at least 2 or 3 areas specifically about energy storage. The wind and solar deployment plan cannot happen without energy storage. The Rural Electrification Corporation has a goal of 24/7 power by 2019. Again, that's not going to happen without energy storage, as well as the National Electric Mobility Mission. So with all these, as well as the Make in India, I think the platform is laid out very clearly. What is just missing piece is having sort of a cohesive policy across all these government departments and having a national energy storage mission. So again, we as India Energy Storage Alliance are working with all the government departments to try to make that happen. So in terms of the market size, we are projecting the cumulative market between 2016 to 2022 to be almost around 70 gigawatt or 200 gigawatt hour in India, out of which almost around 40% is an existing market. So again, it's not a completely new market, particularly for the backup power for residential, commercial, telecom tower, the market already exists. But then some of the new applications such as electric vehicles, the solar integration, renewable integration, and ancillary services will also drive growth of new technologies. And again, this is not just going to happen in future. Some of the things have already started happening. AES and Panasonic has already announced a 10 megawatt hour project at one of the manufacturing plants for Panasonic. Gift City in Gujarat, they are currently evaluating up to 40 megawatt of energy storage as part of the overall peaker requirement for the city. National Thermal Power Corporation is looking at deploying a 20 megawatt solar storage hybrid for Andaman Nicobar Island for the application I mentioned earlier. SECI is looking at up to 100 megawatt storage. Already 10 megawatt RFPs are already out, and another 20 megawatt RFPs are expected to be released by end of this month or early next month. Island FS has already announced that for their solar park in Rajasthan, they are looking at deploying storage along with 500 megawatt of solar. And last year, MNRE had called for expression of interest where they have received more than 40 applications. So again, number of these pilot projects are expected to go live in next 1 year. We are expecting almost close to 50 to 100 megawatt of energy storage projects will get announced before end of this financial year. So just a quick word about IESA. So IESA was created in 2012 to start accelerate deployment of energy storage and microgrid technologies in India. We started with just 5 members in 2012. Now we have grown to more than 60 members, and we are doing number of things, including driving an industry academic collaboration. We are looking at actually setting up an energy storage focused accelerator or incubator with Visit AI in Mumbai, with Visit AI and IIT Bombay, and also there are a number of other research collaboration opportunities which we are exploring. If you want to stay informed about it, there is a free newsletter available for anyone who is interested, and then there are a number of newsletters as well as the RFP dashboard which is available only to members. I'll also like to take this opportunity to invite all of you to join us in Mumbai in January 2017 for 4th International Conference on Energy Storage and Microgrids, which we are hosting in partnership with IIT Bombay. Again, we have been getting participation from more than 15 countries. Around 500 people are expected to be there at this conference. So to conclude, India presents a huge market for renewable as well as energy storage technologies. We expect that India is not only going to be just a big market, but also India can become a big manufacturing hub and start exporting these products around the globe. And Indian policymakers are starting to take steps which can help accelerate this transition. So again, if you have any questions, I'll be happy to answer. At end of the session, we'll take the questions common across all the speakers. So again, feel free to let us know. Here are my contact details, again, we are a small enough group where I'm pretty sure everyone will exchange cards at end of it. So thank you very much.